Welcome back, student. Today we are going to study electronic configuration of elements having atomic number 11 to 20 according to Abba's principle. My dear student, in the previous video we have studied electronic configuration up to neon. The atomic number of neon is 10. So our series we will start from sodium. Sodium atomic number 11. Electronic configuration 1s2, 2s2, 2p6, 6, 7, 8, 9, 10. And now we are going to write 3s1. The next element, sodium. After sodium comes magnesium and atomic number is 12. Its electronic configuration will be 1s2, 2s2, 2p6, 3s2. Here, my dear student, the capacity of s orbit is completed. Now we can enter in the next. The next element is aluminium. Atomic number 13. Its electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p1. Let's count the number of electrons. 6, 7, 8, 9, 10, 11, 12. Our electronic configuration is correct. 14. The next element is silicon. Its atomic number is 14. Its electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p. 1 is over, so here we will write 3p2. Sodium, magnesium, aluminum, silicon. The next element is phosphorus and its atomic number is 15. Its electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p3. Let's count the number of electrons. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Our electronic configuration is correct. The next element which we are going to write is sodium, magnesium, aluminum, silicon, phosphor, sulfur. And its atomic number is 16. And its electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p1. 4. Let's count the number of electrons. 6, 7, 8, 9, 10, 10 plus 2, 12, 12 plus 4, 16. The next element which we are going to study is chlorine. Its atomic number is 17. Its electronic configuration will be 1s2, 2s2, 2p6, 2p6, 3s2, 3p5. 6, 7, 8, 9, 10 plus 5 plus 2, 7, 17. The electronic configuration is correct. The next element is argon and its atomic number is 18 and its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6. 6, 7, 8, 9, 10 plus 2 plus 6 is 8, 18, and here our electronic configuration is completed. The next element is potassium. Atomic number of potassium is 19. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, and then the next subshell will be 4s1. Number 20. Calcium. Number 20. Calcium, atomic number 20, electronic configuration 1s2, 2s2, 2p6, 2p6, 3s2, 3p6, 4s2. My dear student, let's count the number of electrons in calcium to verify our electronic configuration. 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 10 plus 10, 20. So here our electronic configuration is correct. My dear student, we have written this electronic configuration from element sodium to calcium for a reason. Now we are going to study or verify the electronic configuration according to Niels Bohr and try to find a satisfactory answer for the question which we have already discussed. So according to the electronic configuration given by Niels Bohr in K, L, M, N orbit, we are going to consider here. First orbit 1s, electron is 2. 2s, 2p. 2s and 2p, 6 plus 2, 8. And the third orbit is 3x1. So we can write here 1. Atomic number 11, electronic configuration 2, 8, 1, that is 2 plus 8, 10 plus 1, 11, correct. A satisfactory answer. Magnesium, 1s2 in first orbit 2. Niels Bohr told that the capacity of first orbit is 2. Second, 2s and 2p, 6 plus 2, 8. It is also complete. The next orbit 3s2, so we will put here 2. So electronic configuration will be 2, 8, 2 according to Niels Bohr, and the number of electrons is 12. 8 plus 2, 10, 11, 12. So the answer is correct. Aluminium, 1s2, 2 will write, 2s and 2p, 6 plus 2, 8, we will write 8. Now my dear student, 3s and 3p, 2 plus 1, 3, so in the M shell there will be 3 electrons. 2, 8, 3. 8 plus 2, 10. 10 plus 3, 13. Our answer is correct. This is also a satisfactory answer. Silicon, 1s2, we'll write 2. 2s and 2p, 6 plus 2, 8. 3s and 3p, 2 plus 2, 4. This is also a satisfactory answer. 8 plus 2, 10. 10 plus 4, 14. Correct. Now my dear student, here 1s2, first orbit completely filled. 2s and 2p, 6 plus 2, 8. Second orbit also completely filled. And the third shell 3s and 3p, 3 plus 2, 5. This is also completely correct according to Niels Bohr. Electronic configuration, my dear student, here we are going to consider the electronic configuration according to KLMN shell. Number 16, 1s2, 2s and 2p, 6 plus 2, 8, 3s and 3p, 4 plus 2, 6. So this is the electronic configuration which was given by the pattern or the formula 2n square by Niels Bohr, and first orbit will have 2 electrons, second orbit will be having 8 electron, and then remaining will go in the last electron. 8 plus 2, 10 plus 6, 16, and the atomic number of 16. So this is also a satisfactory answer. My dear student, now we are going to arrange the electronic configuration of chlorine. 1s2, first orbit 2, 2s and 2p, 6 plus 2, 8, 3s, 3p, 5 plus 2, 7. So the electronic configuration is 2, 8, 7. Argon, 1s2, correct. 2s and 2p, 6 plus 2, 8. 3s and 3p, 6 plus 2, 8. My dear student, this is also a satisfactory answer. But my dear student, in Niels Bohr, he said that first orbit will have 2 electrons, second orbit will have 8 electrons. So according to Niels Bohr, first orbit 2, second orbit 8, and the third orbit will have the capacity of 18 electrons. So if a definite pattern is used, you will think that whenever you are writing the third shell, you have to go on filling the electrons up to the maximum number 18. But it does not happen because in Abbott's principle, the energy levels are given in a series which we have already discussed. Now, from this series, we will try to write the electronic configuration. And this electronic configuration is given in 7th standard, and the reason for that electronic configuration is Abbott's principle, and according to Abbott's principle, we are going to count. 1s2, 2, 2s and 2p, 6 plus 2, 8, correct. 3s and 3p, 6 plus 2, 8, and then the next orbit is going in 4s1, so here we have to write 1. So the electronic configuration of the element number 19, that is potassium, is 2881. It is not 2889. Got it? Now again we will count the electronic configuration of calcium. 1s2, 2, 2s and 2p, 6 plus 2, 8. Now here you will think, my dear student, the capacity of the third shell is 18. You will go on increasing the number of electrons from 8, 9, 10, 11, 12, but it does not take place because Abbott's principle has given us the orbit in the increasing order of its energy, and through this the answer will get to the electronic configuration of calcium, which is given in 7th standard textbook. 2, second shell is 2s, 2p, 6 plus 2, 8. Third is 3s2, 3p6, 6 plus 2, 8. And the next is 4s2. So the fourth shell we are going to write 2. My dear student, here we are going to count the electrons. 2 plus 8, 10, 18 plus 1, 19, correct. 2 plus 8, 10, 18, 19, 20, answer is correct. So my dear student, when the number of shells goes on increasing, then we come to the conclusion that Niels boron electronic configuration is applicable and easily understood till argon. But in the further studies, we have studied that each cell is further divided into subshell, and therefore we have studied SPDF as a subshell. And according to Abbott's pattern, we have decided the series of subshell in which the electrons are added in the increasing order of their energy level. We have already seen S cell will have 2 electrons. That is, the maximum capacity of S cell is of 2 electrons. P subshell will have the maximum capacity of 6 electrons. D subshell will have the maximum capacity of 10 electrons, and after this maximum capacity we cannot put the electrons in that particular shell. At the last, my dear student, we have seen that Niels Bohr gave the electronic configuration of the element on the basis of the formula 2n square, where K, L, M, N shell were considered. But after further studies, we have learned that this K, L, M shell are further divided into subshell, and these subshells are named as SPDF subshell. Then we also studied the Abbott's principle. In this Abbott's principle, a definite pattern was given in which electrons were added in different subshell according to the increasing energy level. The capacity of each subshell was also decided. S subshell has the capacity of 2 electrons, P subshell has the capacity of 6 electrons, D subshell has the capacity of 10 electrons, F subshell has the capacity of 14 electrons, and therefore when we study the electronic configuration of potassium and calcium, we get this electronic configuration according to Abbott's principle. That's all, students. We'll stop here. Thank you very much.